tilt at this moment. It's just we don't know the best way to use it or how long it's going to last. Also, one of the recommendations had been that if the disease moves through avocado roots to adjacent avocado trees, that you would want to remove some of your avocado. So you would have a positive tree, and then the suggestion was you would remove adjacent avocado trees. Okay, so we had our ag economist look at some of this, and a preliminary analysis of the effect of avocado tree removal on grove profitability suggests that a maximum of 15 to 20 trees in a 100-acre tree grove and 8 to 11 trees in an 88 tree per acre grove could be removed and the grove remain economically profitable. But if you go above that, then it starts to get dicey. Of course, the results of this analysis depends upon avocado prices, the cost of the tree removal and destruction, and any other treatment costs. So, concluding that thus removing the 2 to 8 non-symptomatic trees adjacent to a laurel wilt positive tree may not be an economically sustainable practice. So here's a grove, and or part of a grove. Here's a positive tree, and so the suggestion would be to remove these 2, or worst case would be to remove all those trees. So all of a sudden you've removed 9 trees with 1 positive find. One thing I want to talk about, we have a small, very small avocado industry located on an island off the coast of Florida called Merritt Island. It's on the east coast off of Brevard County. And it has had, the beetle and the disease has been present in the native trees there for about 4 or 5 years. And so we have been up to that island, up to that area repeatedly. In fact, that's where we have a major experiment going right now. And so those avocado groves and trees are surrounded by dead and declining red bay trees. And we have found, without just observing over this period of time, these avocado groves have not been decimated over a 4 or 5 year period by laurel wilt. In other words, the disease has not just come in and swept through those avocado groves and killed all the trees. So over this period, while the red bay trees are being attacked, there appears to be only random, limited attack of the adjacent avocado trees. There is a potential for this to change once the red bay population is devastated, however. So we're not sure what's going to happen after that. And the other observation is that large, mature trees have usually not died quickly, but in sections over time. And Randy alluded to this previously. So you may have a half of a tree start to go and the other half is still viable. And so, for example, 1 or 2 major limbs would show external symptoms and the others wouldn't. So with these research findings and observations suggest that red bay ambrosia beetle and laurel wilt has not quickly overwhelmed the avocado groves in Merritt Island, that the beetle is more attracted to red bay and swamp bay than avocado trees, that chipping infested wood suppresses the beetle, laurel wilt does not survive in chipped wood, that the beetle flight activity is highest during the late afternoon or early evening, and that most flight is within 15 feet of the ground, that avocado may not be a good host for red bay ambrosia beetle reproduction, and then all this suggests that red bay ambrosia beetle laurel wilt suppression may slow the spread of laurel wilt. So, some of the key points: this is an insect vector disease, and that is, at least so far, only the red bay ambrosia beetle has been shown to transmit laurel wilt. Also, that there's, as I mentioned before, no proof that laurel wilt moves through root grafts, although this may happen. So, a key component is early detection. Scouting is the key to reducing the beetle population and limiting the spread of the disease in the agricultural area. So with that, we've been working with the industry on an industry-wide early detection and suppression of laurel wilt. And the strategy is this industry-wide early detection and control of the red bay ambrosia beetle and thus the spread of laurel wilt. And the idea is to constantly control or suppress the beetle population in the commercial agricultural area, not let it get established in the agricultural area. We do know that over time, that there's going to be a loss of the urban or dooryard avocado trees in Miami-Dade County. And there's not going to be, and there hasn't been any program to try to suppress or remove these avocado or native trees that are in the urban landscape. That's just not going to happen. So we know over time those trees are probably going to be eliminated and then eventually be eliminated as hosts. We also know that the loss of the adjacent red band swamp bay trees in the natural area is also going to occur. And so what's going to happen over probably a 2 to 3 year period is you're going to see in the urban area the loss of the avocado trees and the native trees, and in the native areas the loss of the voracious hosts in those areas. And you're going to have this ever-widening perimeter of dead host trees. But at the same time, as those trees decline and decay, they will no longer be sources for new beetles to be reproduced. So you'll end up with a dead zone. Some of the other issues, of course, are abandoned groves and what to do with those. So over time, the number of urban host avocado and urban and natural area native trees will decline. So may the beetle population, which is what they have seen in central Florida, that as the host trees are eliminated, the beetle population declines. So this may provide a buffer adjacent to the agricultural area. So the idea in the production area is to keep the beetle population to a minimum by scouting and control or suppression. Once the urban avocado and the native tree populations are decimated, a laurel wilt may be more manageable in the production area. That's the idea. So, the control strategy, detecting infestations as quickly as possible. And this will provide an opportunity to suppress the beetle and the disease. Remember I told you that the beetle takes about up to 50 or 60 days before it emerges from a host tree. So that gives you about 50 days to find any suspect tree for the disease. So you've got a window between, let's say, 30 and 50 days. So what we're suggesting is ground scouting of the groves as frequently as possible. So we've been training grove workers on how to spot trees that may be suspicious for the disease and to report that. We've also been advocating monthly the periodic aerial surveying of the agricultural area, where we can locate trees, suspicious trees very quickly, and then sampling the suspicious trees for laurel wilt, and then waiting for verification of the cause of this decline, because there are many other things, as you well know, that can cause an avocado tree to decline. And we don't want people panicking or removing trees needlessly if it's not laurel wilt, because lightning, flooding, drought, mechanical damage, other ambrosia beetles can cause problems as well. And so if it turns out to be laurel wilt, then control action is warranted. So this is a map showing you South Florida, Miami-Dade County, and this is the avocado production area, and where the survey, the aerial survey and ground surveying has been done. And we divided the industry up into 4 quadrants to make it easier to do this type of surveying. And so what we've done is hired a helicopter and bought a GPS unit, and then we've been using the GPS unit to mark the location of suspicious trees. And then we use Google Earth to download that information and identify where it is on a map. This information then is provided to Alan Flynn, who is the avocado administrator, and he distributes this to the avocado industry. The growers then take that information and go out and ground truth their avocado groves wherever there are suspicious trees. Sample the trees, and then if control action is warranted, remove that infested material. So this is just the Helicopter Partners is the name of the company. We use a simple Garmin handheld GPS system. There's $300 for that. We fly between 100 and 300 feet in a grid-like pattern. And then groves or trees with trees of interest we mark on the GPS. This is just to show you some of the first 3 surveys. And the blue line here, the zigzag line, is the helicopter trail. So we're able to visualize how the helicopter flew after we do these.